Okay, in this video we're going to go through some of the worked problems in the equilibrium chapter. Okay, for the first problem, factors that affect the rate of a reaction, it says to indicate whether the following changes will increase, decrease, or have no effect upon the rate. So if we increase the temperature, that should cause more collisions, and that would result in a faster reaction. For B, if we increase the number of reactant molecules, that means there's going to be more molecules floating around, so therefore there's going to be more collisions possible, and the more collisions possible, the faster the reaction. And if we add a catalyst, that should also increase the rate of the reaction. And therefore you can see it says increase, increase, and increase. Okay, for the next one, we're supposed to write an equilibrium constant, an equilibrium expression for the following. And in order to write the equilibrium expression, we need to do products over reactants raised to the power. So I'm going to put SO3 on the top, and it's squared because I have a coefficient of 2. Then O2 is going to go on the bottom, and SO2 goes on the bottom, and it's squared because of its coefficient of 2. So I put the products on the top and the reactants on the bottom. In the next one, I have something that's heterogeneous, which means they don't all have the same phase. So in this case, I still do products over reactants, but I only use things that are aqueous or gases. So in this case, I can see that my chlorine, which is a product, goes on the top, and it's squared because of the 2. The water does not appear because it's a liquid, and I don't include liquids or solids. And then I have my oxygen on the bottom, and then I also have my HCl, and it's to the 4th power because it has a coefficient of 4. So once again, no solids and no liquids. In the next one, they want me to find the value of Kc, and they've given me concentrations. So the first thing I want to do is set up my expression. So I'm going to have NO2 squared over N2O4. So I'm going to put in the value that I have for NO2, which is 0.31, and it's squared. Then I divide by my N2O4, which is 0.45, and I should get 0.21. And there would be the expression that I used. In the next one, they've given me concentrations again, and I have to find the concentration of a missing one, and they've told me what the value of K is. So the first thing I do is set up my reaction for the expression. So I'm going to have products over reactants, and none of these have any coefficients, so there's not going to be any squareds or anything. And I'm going to plug in the values that I know, which is 0.64 for the CO, 0.25 for the Cl2, and I'm going to plug in 5 for my Kc, and I'm going to be trying to find the COCl2. So in order to do that, I'm going to take the Kc times those two. So 5 times 0.64 times 0.25, and I should get 0.80. And the big M stands for molarity, which is the concentration. Okay, in the next one, I have to decide what the effect of decreasing the volume of the container is going to be for each one. So for each one of these, if I decrease the volume of the container, it's going to want to shift, because if I decrease the volume, that's going to increase the pressure. So if it increases the pressure, it's going to want to shift to decrease the pressure and get rid of that stress. And to decrease the pressure, it needs to shift to the side that has fewer moles of gas. So for the first one, this has 3 moles of gas because 2 plus 1 makes 3 moles. This side only has 1 mole. So in that case, it's going to shift to the side with fewer moles of gas, which means it's going to shift in the direction of the products. For B, I have 2 moles of reactants, and I have 2 plus 1, which is 3 moles of product. In this case, it's going to shift to the side with fewer moles of gas. In that case, it's going to be shifting toward the reactants. And in the last one, I have 2 moles on the reactants and 2 moles on the products. So in that case, it's not going to shift either direction because neither side has fewer moles of gas. The next one, I'm looking at temperature changes. So now it depends on whether the reaction is exothermic or whether it is endothermic. So for the first one, if the temperature is increased, it means it's going to want to shift to decrease the temperature in order to get rid of that stress, which means it's going to want to shift away from the heat. So for the first one, since it's exothermic, if it's shifting away from the heat, that means it's going to shift toward the reactants. And on the second one, since this one is endothermic and that the heat is on the left side, that means it's going to shift toward the products in that way to get rid of the heat. And that is the end of the worked examples in Chapter 9.